Class methods and class variables. In this video, we will define and create class methods and class variables. Okay. Early in this unit, we learned about instance variables and instance methods. We learned how each instance of a class has its own set of instance variables. For example, each rectangle has its own width and its own length. We also learned how each instance of a class uses instance methods to operate on its own data. For example, when we invoke rec1.getWidth, it gives us the width of the rectangle named rec1, not any other rectangle, nor does it give us any general width value. No, it gives us the width of the rectangle named rec1. In this video, we will learn about class variables and class methods. Class variables belong to the class, not a specific instance of the class. They are also known as static variables. Class methods operate on class data, not on specific instance data. They are also known as static methods. To help with understanding class variables, I like to use the water bottle analogy. An instance variable is akin to each student in a class having their own water bottle. When a student drinks half of their own water bottle, only that student will have half of a whole water bottle remaining. Drinking from their own water bottle doesn't affect any other student's water bottle because each student has their own. A class variable, however, is akin to all students in the class sharing the same water bottle. If a student drinks half of that water bottle, then the entire class will have half of a water bottle remaining because they're all sharing the same bottle. To help with understanding class methods, I like to use the student analogy. Using an instance method is akin to seeking information about a specific student. For example, a specific student's GPA, or the number of tardies they have, or the number of absences they have, or their grade classification, so on and so forth. Using a class method is akin to seeking information about students in general. For example, how many credits are needed for a student to be a sophomore, or what GPA is needed to be considered cum laude, or how many students are currently enrolled in the school, so on and so forth. This kind of information isn't dependent on a specific student. It's simply information about students in general. So, how do we write code for class variables and class methods in our program? The rules for writing a class variable is basically the same as for writing an instance variable with just a couple of small differences. First, you got to put the word static after the word private to indicate that this is a static variable, a class variable, not an instance variable. And we also got to give it an initial value. With instance variables, we don't need to give it an initial value because those variables get their initial values when the objects get created. However, since static variables don't belong to any specific object, it's good to initialize them right when you're declaring them inside the class. Now, notice that the name I gave this method is total rectangles. That's because the purpose of this variable will be to keep track of the number of rectangle objects that have been created in my program. How am I going to do that? Well, inside my constructor, I'm going to add a line of code to where each time the constructor gets called, the static variable will get increased by 1. It'll get incremented. This way, every time a rectangle object gets created, the variable will get incremented. Then I'll have a static method that'll return the value of that static variable whenever I need it. How did I make that method static? By writing the word static after the keyword public. Now, that all being said, you might be wondering, why make this method static? If all it's doing is simply returning the value of total rectangles, couldn't we have simply kept it an instance method? Couldn't an instance method have done the exact same thing? And the answer to that is yes, it could have, but with limitations. And that limitation will become clear in a moment when we discuss the main method. So let's go to our main method. Inside the main method, we create 4 rectangle objects. Now remember, every time a rectangle gets created, the static variable, the class variable, gets incremented. Thus, when I print it out using the getTotalRectangles method, 4 gets output to the screen because that's how many rectangles got created. Thus, that's how many times the class variable got incremented. Now, one thing I want you to notice about how I called the method getTotalRectangles is that in front of it, I put the name of a class. I didn't put the name of a specific object, right? I put the word rectangle. I didn't put the name of a specific rectangle. The reason why the compiler allowed me to do that is because the method is static. And the advantage that comes with that is that we don't need an actual rectangle object to exist in order to use this method. Anytime we want to use it, we just simply type rectangle.getTotalRectangles. And this makes sense because the method isn't dependent on any object. Therefore, it wouldn't make sense to call it from a specific object. Now, a method like getWidth, for example, now that it would make little sense to make it static because you're not going to say rectangle.getWidth. Obviously, if you're trying to get the width of something, you're trying to get the width of a specific rectangle object. So a method like that, it makes total sense to keep it non-static because it is meant to operate on a specific rectangle. But the getTotalRectangles method, not so much. Thus, to use it, all we got to do is simply type the word rectangle in front. Likewise, if I wanted to access the static variable, the class variable, and that variable was public, all I would need to do is type the word rectangle in front of it. Because once again, the variable does not belong to any specific instance. It belongs to the class. Now, obviously, this code would not compile since we made the static variable private. But had we made it public, this is how you would access it. That all being said, you might be shocked to find out that you already have experience dealing with static methods. Okay. Earlier in this class, in this unit, we worked with the character class, which is known for having plenty of useful static methods. Some methods like isLetter, isDigit, isLetter or digit, isLowercase, so on and so forth. All of these methods are not dependent on any specific character object. We did not need a specific character object to use it, because what each of these methods all did was simply give us information about characters in general. They weren't giving us information about a specific character object. And that is what enabled us to use them without ever having to create a character object. Another class that's popular for having a lot of useful static methods is the math class. Math methods like absolute value, the power method, the square root method, max, min, random, so on and so forth. Each of these methods, we don't need to create an actual math object to use them. We can just use them whenever we want to by typing the word math in front. And that makes total sense because the jobs of these methods is not to give information about a specific object. It is to give us information about numbers in general.